Hi, my name is Timothy, and I'm an engineer at NVidia. And for today's presentation, we wanted to present what me and my team has been working on, which is a desktop application called Nsight DL Designer, short for Deep Learning Designer. It is an application that's part of the Nsight tool suite, like Nsight Compute, Nsight System, or Nsight Graphics. But it's specifically designed and targeted for deep learning designer and user which are working inside the ONNX ecosystem. So first, I need to give a high-level overview of what Nsight DL Designer is and how it integrates with the ONNX ecosystem. So at its core, DL Designer is actually an IDE, so an integrated environment for developing high-performance deep learning network. And it has features across all the key milestones when you're actually developing or iterating on your deep learning network. So DL Designer uses ONNX as its file format to represent the model. You can open an ONNX model inside of DL Designer, can visualize it. It can represent in a graph all the operators, the connection or links between those operators. You can inspect attributes for each operators, create or edit initializer, etc. The next big feature is to actually profile the model inside of DL Designer. There's an integrated inference profiler. And that profiler, I'm going to give more details on that later, but generate a profiler report. Through that profiler report, you can quickly identify the bottleneck of your network. And it's going to drive the next steps of your workflow, which is essentially debugging or optimizing your model. So once you've identified the kernels or the nodes that perform not as you expect, then you can go back to your model, make some edits, to try to improve the performance. It can be by modifying the model architecture, modifying some attributes, etc. You can also leverage some of the optimization passes that are implemented directly in DL Designer, like, for example, constant node folding, unused node removal. And DL Designer can also help you set up quantization for your model, so it can be leveraged by TensorRT or any other backends that can use quantization. And finally, once you've done a few iterations of profiling your model, modifying it to improve performance, then you most likely want to actually deploy your model to your target application. DL Designer supports two deployment options, or two big deployment options. The first one is a vendor-neutral deployment option. Essentially, you can save or export your model outside of Nsight DL Designer back to an ONNX model or ONNX format. And that can be processed or consumed by any ONNX-based application, like ONNX Runtime. There is also an NVIDIA-specific deployment option through TensorRT. So DL Designer is capable of exporting a TensorRT engine file out of the ONNX model, and that can be consumed by any TensorRT-based application. So some more information and details on the model visualization and editing feature of DL Designer. Firstly, we've seen in the past few years that ONNX models and deep learning models in general are getting larger and larger. We've seen models with thousands and thousands of nodes. So it was very important for us that inside of DL Designer, you can easily navigate through these graphs and large graphs. And we work on a feature, for example, which is called a Layer Explorer, which lets you easily filter nodes in your graph based on the node type, the node name, some specific attributes, anything to make it easier for the user to actually find the node that they're looking for inside the large graph. And on the ONNX integration, so DL Designer follows the ONNX spec 1.17 and its features. It also supports all the ONNX standard offset from offset 1 to 21 included. It supports fully local function and subgraph. And on the inference side, it's integrated with ONNX Runtime 1.21 currently. So that's another key aspect of Nsight DL Designer. With each new release of DL Designer, we try to follow with the latest release and the latest features that comes out of the ONNX community, whether it's from the profiling side with ONNX Runtime to ensure that our users are getting the most optimized kernel that are updated with ONNX Runtime or new operators. It can also come from a new spec that introduce new features like local function in the past few releases. it's important for us that all those features are available to the user inside of DL Designer as soon as possible to, again, improve their workflow in general. And as mentioned before, DL Designer is a full-fledged ONNX model editor, so you can freely edit your model inside of DL Designer. You can add nodes, remove nodes, create links, create and edit initializer. Essentially, you can modify completely your graph freely inside of DL Designer. There's even a built-in type checker. So as you edit your model, the type checker will automatically validate your model to make sure that there's no model architecture issues. Maybe there's shape mismatch. There can be attributes that don't work anymore after you made some edits. So rather than having to wait the moment where you profile your model to see all those errors reported by the backend, you're going to see those errors reported as you edit your model inside of DL Designer. Again, to improve your iterations and your workflow when editing your model. Now some information on the inference performance profiler. So DL Designer integrates two different backends, ONNX Runtime and TensorRT. On the ONNX Runtime side, we support currently 3 execution providers, CPU, CUDA, and DirectML. DirectML is currently only supported for Windows platform. And whether you use ONNX Runtime and TensorRT, DL Designer will generate a profiler report. The profiler report will contain all the information necessary for the user to identify the bottleneck. And it will present all this information in a concise way. The way to present the information, firstly, is with a timeline. So there's a timeline that shows all the profile kernel and the ranges. So you can see each kernel, how long each kernel took, what's the name of the kernel given the backend, and that helps you identify quickly which range takes the longest, for example. If you're profiling with TensorRT, you also get additional metrics, GPU metrics, like memory throughput, SM utilization, tensor core utilization. That's also displayed in the timeline. So that's another piece of information to identify potential kernels that are underutilizing your GPU. And that might give you an indication on what change you need to do. In any backend, there's always a table that lists all the profile kernels and additional information on those kernels, like the input and output dimension, the type of the kernel as reported by the backend, the precision that was used by the kernel. So all this information are available. There's also a bunch of charts to give you quick information, like the average latency per layer type or the precision per layer type, just that, again, quick to identify issues with your model or the performance of your model. A major feature that comes from the integrated profiler with DL Designer is the easy correlation between a profile kernel and the actual source ONNX node. When you're using a profiler, it usually just reports which kernel, the performance of each kernel, but it can be quite tricky to link back from that kernel back to the source ONNX node that you actually need to modify to improve your performance. And DL Designer does that work for you. So it does the correlation between the kernel that was profiled by the backend and from which ONNX node in your model it actually came from. This correlation extends to local function when you're profiling with TensorRT. This means that if a kernel comes from an ONNX node that was part of a local function, we're actually going to put that information in the profiler report. And we're also going to group all the kernels that come from the same local function instance together, grouped together. So you can also have some hierarchy information directly in the profiler report if the source model was actually using local function. So I was supposed to make some live demo about those local function, but I think there's technical difficulties right now that doesn't allow me to do live demos. But if anyone is interested to see DL Designer, a quick demo of DL Designer, we can follow up in one of the breaks this afternoon, and I can make a quick demo on my laptop if that interests anyone. Or you can also just download DL Designer on your own time to test it out, obviously. I probably want to describe a little bit the live demo regarding model quantization, since I haven't really talked about it. So I think I just mentioned it at the beginning that DL Designer can help you quantize or set up your model for quantization. So this is specifically targeted for TensorRT, and TensorRT has very specific rules on how to set up quantization in your model by placing QDQ pairs, specific place in your graph to actually enable quantization for your operators. That can be quite tricky, especially if you have a model that's not quantized at all. You need to bring it to quantization. You might need to make a lot of edits to place all those QDQ pairs a bit everywhere in your model. So you can do that quickly with DL Designer by essentially just selecting a portion of your graph, making a few clicks, telling DL Designer, well, I want that subgraph to be quantized to int8, and DL Designer will automatically put those QDQ pairs where it needs to be towards the input of that subgraph and the outputs of that subgraph to set up quantization for you. So it's easier than having to do it manually or use some kind of API to make those modifications. Before I wrap up this presentation, we wanted to give some feedback on our experience with ONNX runtime profiling inside of DL Designer. We've had some trouble, mostly because we found that there is a lack of official CLI or front-end tool for ONNX runtime. There's obviously the C++ and Python API, but there is no front-end tool that implements this API as part of the ONNX runtime repository. So we've been relying on ONNX runtime perf test, which is actually a CI or testing tool, part of that repository. That was doing the job for us, but it's not ideal, and it has a couple of drawbacks. The first one is that since it's just a CI tool, it's not actually built and deployed in the release package of ONNX runtime, which means that we need to, NVidia built the ONNX runtime perf test binary ourselves for each platform that we use, and every time there is a new ONNX runtime version, we need to, well, rebuild that binary, so it's a bit of a pain. Also, that tool doesn't expose all the options from the API, so it doesn't have all the profiling option and also not all the option for each execution provider. So it can be an issue when you want to use these options. And finally, when you're trying to load weights, currently it's undocumented how you're supposed to name weights to be used by the ONNX runtime perf test binary. And if you find out the current design looking through the code, the current design is quite impractical. I'm sure it's mostly because it's supposed to be a CI tool and it's set up for the testing pipeline more than it's made to be used by actual users. But yeah, it's a drawback for us currently. So we thought it was worth mentioning during that meetup if maybe there's other users or developers in the ONNX ecosystem that feel the same way. Maybe there's something that can be improved there. And as a final announcement, Nsight DL Designer 25.2 is available. You can download it through the NVidia developer portal, or you can just look for DL Designer on search engine. You should find it. We're always looking for partners to make DL Designer better, and we specifically value feedbacks from our user to guide our future direction. So if you think that DL Designer can help your workflow or help iterating on your model, please try DL Designer and share any feedback or feature that you want to see in DL Designer. You can send that feedback to that email address that's showing the slide right now, but you can find that email also in our documentation later. And yeah, that's my presentation. If there's any question, I'll take them now.
I was wondering how easy or hard it is to have a div feature for the designer.
Yes, this is a feature that has been requested already. When you're making edits to your model, you want to essentially see what the modifications are between multiple versions, right?
That's right.
Right. This is something that we are considering. Right now, it is not easy because, yeah, doing a diff on this kind of graph can be tricky, and also how to actually represent the diff. You can always represent it in a textual way, but that's probably not the best way. So we're still kind of working on that, but that's definitely on our radar for sure.
Yeah, sometimes I would imagine that I want to know, for example, I did some edits, what are the effects, what's changed, how do they manifest in the profile, etc. So I was wondering.
Yeah, and I think we also extend that ID to the profiler report. As you mentioned, if you have multiple versions of your model and you're trying to see which one perform better, it might be also interesting to actually be able to diff the reports directly if they come from the same model to see which kernels perform better, what's the difference between. So yeah, definitely diffing is something that we are looking for future versions.
Cool. Thanks.
Any other question? All right. Thank you.